got the last thing that you said. Sorry, Anna.
How long have you been a Lenser engineer?
Oh, it's doing 5 years now in May. So yeah, I think that I turned 5 years like 3 days ago or so. So yeah, 5 years.
That's like 30 real years in Lens's years, I think. It works.
Indeed, yeah.
Awesome. Well, appreciate you joining today, especially since you played a role in developing this feature that I know is quite a hit with customers, definitely a differentiator for us. We'll get into why that is in a second, because today we'll be talking about SQL processors. And if this is a new concept for you, to put it into context, when we have Kafka, which is a distributed event log, we're writing to this event log that's being stored on our Kafka brokers by a variety of applications. And commonly, when we need to sync that data from Kafka to an external store, it requires some transformation. And at Lenses, we have our own SQL engine that we've developed for working with Kafka data, and it comes in two flavors. So we have SQL Snapshot, SQL Studio, which is used for using SQL syntax to run queries on data as it is in Kafka right now. So alleviating the need to sync to an external store and Elastic to be able to run queries about your data in Kafka. You can open up SQL Studio, formulate some simple SQL or complex SQL queries, and we'll consume that data directly from Kafka and present it in your browser. So it's a fantastic tool, a big hit with our customers for troubleshooting issues, especially in production, but also just understanding your data as it is in Kafka today. So kind of alleviating that observability gap that you typically get when you're using Kafka and distributed event logs. That same SQL syntax is then used for our SQL processors as well. So you can use SQL Studio, filter data, test a join, and copy that query, check the output, verify that that's what you want, and then actually deploy a stream processing application using that same SQL code. So with SQL Studio, we're asking questions about our data, trying to understand more, gain some observability into that data layer. And then with SQL processors, we're actually transforming the flow. So that the analogy here is that with SQL Snapshot, you've got a case of cans, you're asking questions about, the cans that you have at that point in time with Kafka. How many are blue? How many are green? How many are cider and beer, to keep the analogy. But then with SQL processors, we're actually transforming the flow down through the production line. So as you produce data into that input topic, you're going to deploy your stream processing application. And as you produce data there, you're going to be either filtering data out, writing to different topics based on a filter, a variety of use cases. And some of those being that are really easy to do with SQL processors. Again, filtering data, so navigating data and filtering out fields that you aren't looking to sync or store elsewhere. You can do windowed aggregations. So since it's an endless stream, we need to window these aggregations. You can get the average of a message field within 15 minutes a day, within that time period. We'll be reformatting some messages a day. So it's really easy to do with SQL processors. And a really strong use case, especially if you're working with legacy applications, something that's writing XML data, very easy to go from that format to Avro. But you can do a lot more, including reshaping, routing and forking data, rekeying data, as well as changing timestamp and metadata there, adding headers, enriching and joining topics and streams, and then even generating sort of a stateful log compacted table within Kafka. All really easy to do just by writing a few lines of SQL. And I'll hand it over to you gently, Fran, because you're the expert here, and I'll rely on you to kind of fill us in on how this works from an architectural standpoint.
Sure. Well, so yeah, what we are mainly doing is that we are grabbing the SQL that we are writing, and we are transforming that into a Kafka stream application. And well, since this is an application, we need to get all the information to establish the connections against Kafka, for instance. So we build a deployable artifact. We are going to call it a deployable artifact because it's not targeting, even when the main target is Kubernetes, probably we are not targeting only Kubernetes. So let's call that this is an artifact that can be deployed to different places. And we then inject into that artifact all the information needed to establish the connection secrets, basically. If we need any password, any sort of certificate, we inject that in a secure way to that application, and then we deploy it. As I was saying, the main target, deployment target is Kubernetes, but we can also deploy, for instance, to improv, which is something more for development, where we are running the application, let's say, as a Java thread. But for going for production, we are actually building a completely isolated application that we deploy to Kubernetes. We are able to assign or customize the resources that application is going to use from the Kubernetes cluster. So we are going to have that completely independent application running and producing the transformations, managing the data that we are interested in. So yeah, building the application, injecting the secrets, and deploying. That's basically the workflow.
Fantastic. Yeah, and like you mentioned, there's the two options there. I love that in process and an option in proc, because you can run those apps locally on that same VM or hardware that you're running the Lenses instance, which is great too, because you have the Lenses box where everything is in an all-in-one Docker container. It's really easy to test things locally and produce your own test data there. But then when it's time for production, obviously you don't want that running on the Lenses instance. And the fact that it deploys on the Kubernetes is really cool for me for a few points. Is one that because you're writing your application in SQL, that kind of lowers the barrier to entry to even more the analyst type personalities and roles where, I know how to deploy a connector. I can get data into Kafka without actually touching code or a CI/CD process. But they can actually transform streams too and get my data to look exactly like I need it to sync into my database. And that's all deployed onto Kubernetes for me without ever having to touch code. I think that's super cool. Then if we can touch on sort of the architectural patterns here.
Yeah, so yeah, as we said, we are building this application and we are deploying somewhere. This time is Kubernetes, but yeah, now what? We need to understand, we need to get some insights on what's happening with that application. If that application is actually running, is it producing stuff, is it stopped, has any error. So once we deploy the application as part of Lenses, we have a watchers mechanisms, we call them that way, that inspect or receives events from Kubernetes. We subscribe to an event channel that Kubernetes provides. So we are able to get all that information, for instance, in this time from Kubernetes, and expose or generate, we are generating our own events, even when we are, both cases, when we are producing data, but also when we are producing any sort of error, we produce those two different events, and we are able to inform the user. We are able to show in our Lenses instance what's happening with those applications, if they are running, or if they are producing any error. If they are producing errors, we are going to be showing those errors inside Lenses, and we will also be able to inspect the logs of the deployed application directly through Lenses, so we can get a specific or an overview of what's happening, but also specific details of the error that the application is producing. I mean, potentially producing. The ideal scenario is that no errors, everything is green, and nothing. We don't have to worry about anything. But of course, these issues happen, and we have to have a way to understand what's going on. So yeah, that's what we are seeing there. We are calling the Kubernetes watchers, that are the ones that are interacting directly against the Kubernetes infrastructure, and then we are producing these events that we understand and expose the corresponding error to the final user. That's mainly it. Yeah.
So not just a deploy to Kubernetes and forget about it. Hope, fingers crossed everything works right and there's never any issues. But actually a full sort of monitoring and observability suite built into that too. Again, super cool, because from an analyst perspective, now I can deploy my own application, and the events and all the logging and monitoring are built into. Cool. Thank you for. And you mentioned something too there, the Kafka streams as well, which is what we are using under the hood. And if that's a new term for anybody, sort of a 101, an explainer of how this worked historically, from what was available first, but also the most highly complex way to develop these kinds of applications was we used to use Kafka consumer and producer APIs, so Java libraries, that we would develop applications to say, I'm going to be consuming from a topic. I'll be applying some sort of transformation using Java code. and that'll be producing to another topic to do this stream processing, right? Because when we're talking about stream processing, we're always both consuming from a topic and writing to at least one topic. Then came along Kafka Streams API. So another set of Java libraries with some intelligence built in to at least know, hey, I'm going to be doing both of these. I don't need to use separate consumer and producer APIs. We have the Kafka Streams library to develop these applications that are going to be doing both. And so that's what we'll be comparing against today is the Kafka Streams libraries and sort of that full workflow. And then the easiest way to develop these applications and deploy them under Kubernetes would be SQL processors, which is using the Lenses SQL syntax. You can develop the full Kafka Streams operations and applications using our SQL syntax and deploy under Kubernetes, which is definitely the easiest way to get this job done, as we'll be showing today. A quick visualizer to help you understand the complexity we abstract from our users is that if you wanted to develop an application to solely split one topic into two topics based on a message data field, here we've got an upstream topic called orders. We have our stream processing application. I think that's like 9 lines of config for this app. And all we want to do is write denied orders to one topic and any order that's not denied to another topic. Very easy to understand what we're trying to do here. If there's ever a problem with this application, troubleshooting, in understanding the expected behavior, it's very easy. And again, lowering that barrier to entry so you don't have to be an advanced Java developer, someone who can look at the code on the left and develop a full application there. But when it's also time to troubleshoot, that app on the left becomes a lot harder. Also, if you're onboarding new developers and new teammates, it's a lot easier for them to understand these transformations in a few lines of SQL than going through a huge repo full of Kafka Streams code. So that's sort of the pain we're trying to address here with SQL processors. And to really highlight that, we have a sample scenario. So today we'll be stepping into the shoes of Optics Financial. We're a financial services provider, and we have a new payment service. It's modern, state-of-the-art, and we're using a Kafka backbone for our microservices. This is a new service we're offering. It's been in production for a while now. We've got sensitive data and private information running through here that we want to make sure we're compliant and that we're always online and producing value to our customers. The new business requirement for this use case is to enable analytics on the payment data. So we've got our microservice, it's using Kafka as a backbone, and we're using that in production. But we'd really like to be syncing this data into a relational data store so we can run analytics and queries on the data historically and retain that data long term. One of the limitations here is that our app is in production, again, with sensitive user data. So our developer needs to be effective in developing this flow, providing this value to his organization, but all the while remaining compliant and not subjecting that actual developer to any sensitive user information. So to give you a sense of what we need to do here and what that upstream data looks like, we've got the screenshot on the right, where one of the strengths of Kafka is that it's very flexible, right? So we're sending XML serialized messages into our topic, and we've got nested data fields, and particularly this splits array, where we've got a nested array, multiple objects here, representing whether or not a financial transaction has been split between two accounts. So we need to account for that before syncing into our relational data store, which is meant for tabular data. And obviously you cannot take in a nested array as it is shaped today. And then we've got some other nesting here around customer info and transaction metadata, which we'll need to normalize. And this is also a very high throughput topic as well. So we'll need to make sure that our in transformation is scalable and the solution is scalable to track that load. So without lenses and using Kafka streams, excuse me. So in the world without lenses, if we had to accomplish this task using this set of data, using Kafka streams, we try to sit down with some users and sort of extrapolate what timeline we'd be looking at here to get everything done, right? So a developer coming online, receiving the request from the business side, saying, hey, we need some analytics here. Please store this data in a relational database. for that use case. So that developer's first going to need to be familiar with the shape of that data. Without lenses, this could mean looking at a schema from schema registry if they have access to that. Since it's in production, they probably can't open a CLI consumer, but maybe they've got a copy in dev that doesn't have sensitive information, and they can do that there. And they'll probably need to look at the producer application code as well. So we can call about a day for that, roughly. Then they're going to need to create a schema for the downstream topic, because we're going to have to consume from that sort of nested rough data in XML. And we're going to need to create an Avro schema. We're also going to be translating to Avro, which is a much more storage efficient format. So we'll need to create a schema for the way we want that data to look like. And then we need to develop our Kafka Streams application. So this includes pulling in all the right dependencies, the correct folder structure, and then actually developing that application using the full Java library. Again, a lot more lines of code, and requires someone who's very familiar with Java and Kafka streams as well, at least able to learn those. They'll need to submit their pull request and go through the Git flow and deploy the application via CI/CD, and making sure that all their monitoring that they need for this application is in place as well. So roughly, that could take anywhere between 7 to 14 days, depending on workload, experience of the developer, and what's going on with that team. Then they'll need to verify that transformation. So they'll need to deploy the application, making sure everything's working correctly, probably CLI consumer in a development environment. If there's any sort of edits they need to make, if it's failing or that actual output isn't meeting the requirements, they'll need to make those edits. And then once that data is looking good in Kafka, then they need to develop their sync connector to store in our relational database. So there's quite a big black box here, depending on experience again and workload. But we can chalk this up to around 19 to 31 days for all of the development work and all the cross-team collaboration between operations and development here. So lots of communication and talking back and forth just to get this use case done. That data is already in Kafka. We just want it normalized and synced to a database. In my mind, it should be a lot easier than this. And with lenses it is. So familiarizing yourself with the data, even in production, super easy. The developer can log into the lenses UI. They can ask questions about the data using SQL syntax. They can open the topic page and view everything as a table. Easy to export that to a spreadsheet and understand trends as well. They can do all of that in production because all this sensitive data is masked there. Next, all they need to do is develop a SQL processor. So much more simplified workflow, not a huge, dependencies and file structures to worry about. They don't even need to be a Java developer. They just need to be a little bit familiar with Lenses SQL, which is all fully documented and links to help articles within the UI. Then they just need to verify that output. Again, all within the same Lenses instance, same Lenses UI. They'll just jump to SQL Studio for that downstream topic and verify everything looks good. If any edits need to be made, you're just editing a few lines of SQL. Then they can even create alerts, and that's a SQL processor with all the monitoring suite built in, deployed onto Kubernetes, so not a shared cluster of resources, but everything is scalable and running as Kubernetes pods. They can create alerts and then develop the connector, again, all within Lenses, deploy that connector to Kafka Connect, and fulfill this business requirement in a matter of days instead of roughly a month, which I think is super powerful. And to give you a chance to see it in action and just how easy it is, I will fire up my data producer and we'll hop over to the Lenses environment. So you can see here, I'm in my Lenses environment for optical finance. And we've got data in our financial payments transactions topic. I can scroll down and view individual messages, or I can view the full topic as a table, which is a lot easier to understand it in bulk. And once you do, you can see this nested object, which is splits, which is also no in a lot of these messages too. So we've got to account for that logic in our Kafka Streams code, or again, our SQL processor. Awesome. So we've got live data coming in. All I need to do is jump to our applications page. I'll go to SQL processors, Kafka live streams demo, and it's going to work. We'll call it working. Now, I've developed this ahead of time. It is a little bit longer than the typical queries we see, but most of this is repeated, and this is so that we can account for the null fields. So we've got basically a repeat of the same SQL processor. This one will handle field messages without the split, which so when that split is null and it doesn't contain that nested array, we're just going to normalize this data out. So we're pulling in some of these fields as is, transaction ID, account ID, transaction type. We're doing some casting too. So we're casting the total amount as double, and we're actually multiplying that by our exchange rate to get the converted amount too, which is very helpful for the analytics side. We're taking a single string, which contains the transaction date, and separating that out into an actual date and time field. So some very simple transformations being done here. And then we're concatenating the customer email, doing some abstraction there since we don't actually need to record that, and storing that there. And then we're also casting purchases as expense or refunds as income. Exact same transformations here, but now we need to account for the actual messages that have our nested array. Again, this is actually very easily to do. So here we're creating a temporary table, and we'll be pulling from that stream instead of the topic as is, so that we can account for where it is not null. And then again, this looks very familiar. It's identical, more or less. The only novel change is that we have a lateral join. So since we have a nested array, we want to actually explode each message, which has those split transactions, into individual Kafka messages. So we'll be doing a lateral join on that array as a split. I'm getting a temporary network error. So let me just reload. This should work. Awesome, no errors. Sweet. And so few lines of code here, again, mostly repeating, very easy to understand because it's in simple syntax. And since I'm running on Box, we'll be deploying in process. But again, this will be running on your Kubernetes cluster, easy to scale up and down these individual transformations. I've even seen customers do that in an automated fashion using our data production alerts. It's going to take some time to come online, but as soon as we do, we start seeing some metrics, which is fantastic. So we've got 730 records in and 853 coming out. Again, that number is going to be more because some of those transactions with the split nested array are going to be exploded into multiple messages. All this data is going to be normalized. You can jump into the SQL page to see that full application code. And then the data flow will show me all of the underlying Kafka streams operations that I don't need to code. And it's also making it very clear that we're starting off with XML data, and then we're ending up with Avro. Awesome. And now that that's deployed, my developer persona, I can jump into topology. I can see my upstream topic here, and then the topic that I'm writing to verify my transformation. I can click on individual messages here and see that everything is normalized. It's all flat, perfect for tabular data. And the aggregate here at the table view. Again, easy to download, share with the rest of the team. I can even back this up to S3 and start syncing this data in real time to my object store. But what I really want to do is get this into my database for my analytics workloads. So I'll just jump over to my connectors page here. Awesome. I'm going to be selecting a JDBC connector. I'll just develop my connector configuration here. Again, all done within the same UI, governance built in. This can be, done in production since the data is being abstracted, and I will deploy my sync connector. Again, a couple seconds, we've got to deploy the connector. Kafka Connect is going to pick up on this connector task, and then it'll start writing messages into my Postgres. You can see here, we've got 971 in, 971 out. That looks good to me. I can jump into my PGA admin and just verify that I'm writing to it correctly. I've got my database and tables here. Might need a refresh. Perfect. Where there was none tables, now we've got some. We've got all of the columns here. If I want to create a query, show you that there's no magic behind the scenes. We are actually writing data. Perfect. We can see all of that data. So we went from nested XML, complex data structures. It's perfect for my microservice application, which is still running in production. Now we're just consuming that data and using it for an analytical workload. And now I can store it long-term in this relational database. I've performed all the transformations I need to get it stored here, and transformed it to Avro as well on that midterm too. So a lot of really easy transformations that we make available with built-in functions and SQL processors. And then you can always bring your own functions too with user-defined functions. Again, all of this done just by writing a few lines of SQL, deployed onto Kubernetes, air handling built in there. You can add some DLQ configurations, and I can even add alerting as well. Perfect. And I can do all of this in production and view all this data because I'm masking the data as well. So we're actually abstracting that customer name and email from that upstream topic, which allows my developer to view this data in production while retaining compliance. Cool. And just to give you the basics of the SQL process that we made, some of the syntax is you're going to be inserting into a new topic, just how easy it is to work with. You're going to select your data fields from that upstream topic. You saw me doing that there with some transformations. And then you're just going to select your upstream topic that you'll be consuming data from. You can apply your lateral joins, your predicates, your filtering here as well. So I hope that was a valuable demo for you. If you haven't used SQL processors yet and you have access to lenses, I definitely encourage you to check it out and give it a shot. We've done a few other of these Kafka live streams on SQL processors as well. If you have any questions, you're always welcome to ask me on Slack too. So definitely join our Slack community. And thank you so much for joining this Kafka live stream. We host these every week, quick 30 minutes, just like we had today. If you have any topics that you would like addressed or talked about as well, definitely reach out to us on our Slack community here. How did I do, Fran?
Cool. Thanks a lot, Adam. Yeah.
Perfect. Thank you for joining, and thank you for all the work you've done on SQL processors as well.
Thank you. Pleasure speaking to you, man.
Awesome. And with that, I think we're good to wrap. Thank you all so much again, and see you next week.
Thanks, everyone. Great job, Adam, Fran.